look at that, it's working. So, today's notes, okay, 4:30, it's Landon's birthday. Landon's 18 years old today, so if you see him, tell him happy birthday. Okay, geometric. So the thing about geometric sequences, so there's geometric sequences today and series. Geometric sequences and series. So again, a sequence is just a list of numbers, like this one. That's a sequence because it's just a list of numbers, okay? And a series means you just add them all up. If you have the plus here, plus, we add them all up, we got a single number. That's a series, okay? All we have here is a sequence. So to be a geometric sequence is that each term is multiplied by the same number. We're going to call that R, just for the ratio. Same number to make the next term. Gosh, I wish I had neater handwriting. I'll try and be neat, because that's pretty sloppy, huh? Each term is multiplied by the same number, R, to make the next term. So we call it the ratio because sometimes you multiply by a fraction. That's why they call it a ratio, okay? But you're going to multiply the same thing over and over again. So we have a formula. And our multiplier is R. That's our multiplier. So R is the multiplier. R is the multiplier. And it's called a ratio, okay? A1 we know is the first term. We know that. A of n is our last term, or the term we want to make. And n is the number of terms, okay? So it's very similar except for the fact that it's a slightly different formula, okay? So let's look at example 1. So now example 1 says write a rule for the sequence. Okay, so I'm going to go, all right, write a rule. I'm going to use this formula, A of n equals A1 times R to the n minus 1 power. Now if you need a rule or a formula, we need to keep n as a variable. Okay, so if we're going to make a formula or a rule, we need to keep n as a variable because we need to plug in a number and then plug in the next number and plug in the next number. So we need a variable to plug into, right? So I'm going to make a formula that fits this by starting with A of n equals A1, which is the first term, which is 5, times my multiplier. Now, what's our multiplier in this case? What's our ratio? What do you guys notice? Yeah, we're multiplying by 3, so the ratio is 3, right? Everybody agree with that? So I'm going to go 3 to the n minus 1 power. Now, all right, do not make this a 15. This is not 15 to the n power. You guys agree? Do not make, I'm making my point clear. Do not, because I see it all the time, like, come on, you guys, don't do that. This is 5 times 3. 3 is to the power, do you agree? Don't make that a 15. That'd be a really bad idea, okay? Because it's not 15 to the power, it's 3 to the power, right? So then we've got a formula. So then from our formula, we could make the 20th term. Now, the 20th term is probably going to be pretty big because you can see how this thing's getting big pretty quickly. So I'm going to use a calculator. So to get the 20th term, we'll just take 20 and plug it in for n. So I'm going to go A of 20 equals 5 times 3 to the 20 minus 1 power. Okay, so depending on what calculator you have, you guys, if you have your phones, it's a little bit hard to put things in too, but I like these big fancy calculators. So I'm going to go 5 times 3 to the power of 19. You're okay with 19? I mean, I could go 20, subtract 1. That seems silly. I could just go 19, right? And so then the 20th term is, wow, it's a big number. I knew it was a big number, right? Let's see if I can write this down. So A of 20 is, let's see, I've got 5, 8, 1, 1, 3, 0, 7, 3, 3, 5. Put some commas in here so I can figure out what it is. So it is 5 billion. let's see, thousands, yeah, it's 5,811,307,335. Wow. Much easier than making the whole thing is to use that formula. I mean, man, if I had to make the 20th term, it'd be a lot of work, okay? Okay, example 2. Write a rule for the geometric sequence where A1 is 54 and A6. Okay, so we've got something going on like this. First term, second term, third term, fourth, fifth, sixth term, okay? What I'd like to do is find the first term. And I'd also like to find the ratio. So I need to find A1 and I need to find R, which is the ratio. Okay, those are the two things I need to find. Well, let's see. I've got this formula, right? I've got this formula, A of n equals A1 R to the n minus 1 power, okay? Let's see. If I plug this in as the sixth term, I actually think I could do this. And plug this in as the third term, I might be able to get the ratio, okay? So if I say A1, and if I call this one A1 for right now, call this A1, and then if I call this one A1, I'd call this one A5, right? No, A4, sorry. So I went back, and I'm just going to call it A1, so I'm going to go back 2, I'm going to call this one A4. So I'm going to say A4, which is 1,458, is equal to A1, which we're going to call 54, is going to be R, which is what I want to find, R to the, well, in this case, it would be, we'd have, let's see, we'd have 1, 2, 3, 4 terms. I'll let you write that down, and I'm going to explain that one again. These are the hard ones, okay? So again, I'm shifting everything because I know what's happening between here and here will be the same thing that's happening between here and here, okay? So if I let this be one A1, I put it here. If I let this be A4, because I'm shifting the whole thing back, right? So there's my A4. So that means I have 4 terms, 4 minus 1. Now let's solve, okay? So the first thing, divide by 54, divide by 54. I'm going to have 1,458 divided by 54, and I get an answer of 27 is equal to R to the third power, right? Well, that's not so hard. Cube root, right? Cube root to solve for R. And then R's got to be 3, right? Well, I know the multiplier. So if I know the multiplier, that means I went times by 3, times by 3. So let's work it backwards. So instead of going times by 3, let's work it backwards. Let's divide by 3. Okay, so if I take 54 and I divide it by 3, I get 18. Divide by 3 and I get 6. So my first term is 6. Okay, now I have everything I need to make a formula. I really do, because I can go back to this. I know my first term for real. I know my multiplier is R, which is my ratio, and I can set my formula. So my formula is going to be A of n equals A1, which is 6, R, which is 3 to the n minus 1 power. Now, what I like about geometric is you don't have to simplify. It's done, because you're not supposed to multiply those anyway, are you? All right, so you're done. There's no tidying it up. That's the formula, okay? Hey, turn the page. How am I doing? Okay? Okay? All right. Turn the page. All right, geometric series. So a geometric series is where we're going to add all terms. And so if I take a look at example 2, that's a geometric series because I'm plus, 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 plus. It's geometric because it looks like I'm multiplying by, what do you think R is in this one? What's R? What's the ratio? What's the ratio? 3. So it's got to be geometric because I'm multiplying by 3, multiplying by 3. So that's what makes it geometric, is we're multiplying, okay? But we're going to add all terms, okay? So we could create the first 20 terms, right? It'll work. Keep multiplying by 3, but this is going to get pretty darn big. And then we can add and add. We got 20 numbers to add up. What a pain. I don't want to do that. So I'm going to use my formula, okay? Now you're definitely going to need a decent calculator to do this formula, okay? Your phone, it'll work, but it's really tedious to use your phone, okay? So I know the ratio is 3, and I know n, the number of terms, is 20, right? Because I need the 20th term. And I know the first term is 2. So let's see if we can set this up. I'm going to go S of 20 equals A1, which is 2, times a 1 minus R, which is my 3, to the n power. Well, the n power is going to be to the 20th power, divided by 1 minus R, which is 3. Okay? All right, I have to be careful when I put it in my calculator. It's really important I remember my parentheses, okay? You have to have your parentheses, otherwise you're going to mess it up, okay? So in my calculator, let's see if I can put this in correctly. So clear. I'll go 2 parentheses. I have to have the parentheses. 1 subtract 3 to the power of 20. Parentheses, right? Oop, no, my parentheses there. Delete. Parentheses. Divided by parentheses 1 subtract 3, or negative 2. Okay, let's see what I get. Should be a bit, you guys agree it should be a huge number? Gigantic number? Okay, yeah, it is a big number because we're adding all these numbers, get bigger and bigger and bigger. Let me write these down. 3, 4, 8, 6, 7, 8, 4, 4, 0, 0, comma, comma. So 3,486,784,400 is the sum. Okay? Okay, example 4. I know it's geometric because it fits. I know this is geometric because it fits this pattern. See that? I mean, it looks just like that. So I know it's geometric. So it's definitely geometric. So I'm definitely going to use this formula, okay? And I know it's a sum because we've learned this week that this symbol means to add them all up, right? That symbol means sum. So I know I'm adding them up. Poor Olin, you're barely hanging in there, aren't you? You need more sleep, Olin. You need more sleep. It's okay. So I'm going to go, I know n is 15. A1 is negative 3, but we can test it, but A1 is negative 3. That's my first term. But you can plug in 1. So A1, you can go, okay, negative 3 times 1.5 to the 1 minus 1 power. It does turn out to be negative 3 because anything to the 0 power is 1. So A1 is definitely negative 3. But I knew it was negative 3 just because it sits right there in the formula, right? I mean, it sits right there where A1 would be, okay? And I also know the multiplier is 1.5. I know R is 1.5. Because it sits right there anyway, right where the multiplier would be, okay? So if I use my formula, right, I'm going to go S of 15. Because I'm using this formula. Okay, S of 15 equals A1. And A1 is, let's see if I can squeeze it in. No, can't. A1 is negative 3 times 1 minus R, which my multiplier is 1.5 to the n power. And the n power, how many terms are there? There's going to be a total of 15 powers, 15 terms, sorry, divided by 1 minus R. That's our multiplier, which is our 1.5. Okay, again, when you use your calculator, be very careful to make sure you use parentheses. Okay. Hey, let's do it. Okay, so we've got negative 3 times 1 minus 1.5 to the power of 15, parentheses divided by 1 minus 1.5, and let's see what I get. Okay, negative, interesting. So if you make this formula, we didn't, it goes positive, negative, positive, negative, positive, negative. So this last term is going to be a negative 2,621. And we'll go round it up to 0.4. How's that? Okay, that's all I have. Homework, write that down there, is page 208. And we're going to do 1 through 11 all. And the extra is going to be 12. We have lots of time. We got some time, but I'll help you with it, okay? I like the shorter period.